Now we will discuss about distance vector routing. This is a diagram given. This is node 1, node 2, node 3, node 4, node 5. Node 1 to node 2 is 1 cost, node 2 to node 3 is 6, this is 2, 4, and from 5 to 2 or 2 to 5 it is 3. So now we will keep on fill up these tables. Okay, so let us start with this one. Okay, so now this is the destination. Okay, so from n1 I will go to the next destination, the distance vector, and what will be the next hop. So suppose from n1 I want to go n1. So what is the distance? N1 to n1 distance will be 0, no problem. And what is the next node? It is n1. So if I want to go from n1 to n2, next destination is n2. Cost is, see, it is 1. And what is the next stop? It is n2. Next I want to go n1 to n3. See, there is no direct path. Now since in distance vector routing, in the initial state, information can only be given from adjacent node. So information to n1 will be come from n2 only, not the other. In the first iteration, only information of n2 will come to n1. So if I want to go to n3, there is no basically direct path, and there is no information of n3 to n2 at present. So in that case, distance will be infinite and there is nothing. Similarly for n4, there is no information of n4, so infinite. And for n5, it is also infinite. So only information is n1 to n1 it is 0, and n1 to n2 it is only 1. Okay, so let us now fill this part, this for n2, the local routing. So again, it is the destination. I am not writing here, I am just writing the value destination, distance vector, and distance, and the next hop. So from n2 I want to go to n1. So what is the cost or distance? It is 1. And what will be the next hop? It is n1. From n2 you want to go to n2. So this distance is 0. Next hop is n2. From n2 you want to go to n3. Distance is 6. This is n3. Okay, you want to go to n4, but there is no currently there is no direct path, so, and no information, so it is infinite. And to n5 it is 3, and it is n5. Okay, now let us say about n3. So initially what in first iteration, n3 has only information regarding n2 and n4. Okay, so let us, it is, so if I go want to n3 to n1, there is no direct path, so it is infinite. n2 it is 6, so I fill up the table. n3 it is obviously 0, because from n3 you want to go to n3. n4 it is that obviously it is 2, n4. And for n5 there is no direct path initially, so infinite, nothing. So from n4 there is only information regarding n5 and n3, no information of n2 and n1. So from n4 if you want to go n1, no information, so it is infinity. n2 no information, infinity. n3 it is 2, next stop is n3. n4 it is 0, n4. n5 it is 4, it is next stop is n5. And what about the n5? So destination from n5 to the direct path is n5 to n2, n5 to n4. So these two information will be come under n5 in the first iteration, and other information, that is n1, n3 will not be there. So n1 it will be infinity, n2 it will be 3, n2. Next it is n3, infinity, n4, 4, n4, n5 it is 0, n5. So in the first iteration, all the tables, routing tables, will be filled like this way. Okay, So after these are all the local routing tables. Okay, so after local routing table complete, then they share this information to the corresponding neighbor only. So after this is filled, they will share this information to here. N2 will share this information to this one, and suppose N4 will share this information to N5, N4. Okay, and what they will share, is they going to share the entire table? No, they will share only this distance vector, only this part, this part, only suppose this part. Okay, so only they will share only this part. Okay, they will share only this part, that is the distance vector. They will only share this part, they will only share this part to the corresponding neighbors. Okay, not this one and this one. Okay, now suppose let us say suppose I am at N1 and I want to go to suppose N2. Okay, so I will give the distance vector. So what is happening at N1? Suppose I want to go to N2. So N2, I can say what are the corresponding, so N1 will get information only about N2, N2 will get information of N1, N3, N1, N3 and N5. Okay, N3 will get information of N4 and N2, N4 will get information of N3 and N5, and N5 will get information of N2 and N4. Just they are adjacent, nothing. Now next part we will come, that is update. How to update? In the first iteration this has been done, and after that this middle portion, that is the distance vector, has been shared to its only to its local routers, sorry, to its adjacent neighbors. Okay, only to its adjacent neighbors. So these are all the adjacent neighbors. For N1, adjacent neighbor is N2, so only this part has been shared to here, and for N2 also this part shared here, this part will share to here, and this part will be shared to N2. So these are all given which will be shared. Now let us do one problem for this next iteration. So at N1, what are the information at N1? This information is shared to here. So what is this? 1, 0, 6, infinite and 3. Now this information is basically coming from N2. So this information is coming from N2 to N1, and we will only now create the N1 new routing table. So let us create, so this is old routing table, now we will create the new routing table with the help of this one. Okay, so again I write this destination, next is distance, and next node. Okay, now let us try to compare. So you are at N1, so you want to go to N1, obviously distance is 0, next node is 1, N1. You want to go to N2, okay, so distance is 1, okay, and next is N2. Now one thing you have to keep in mind, suppose we will calculate it like this way. If you want to go from N1 to N2, so how will be the cost will calculate it? That is N1 to N2 the cost, and from N2 to N2 we will add this part. Okay, so let us see N3, from N1 to N3, so N1 to N3, so initially it was infinite, but now see N1 to N3 if you want to go. Okay, so what we will this N1 to, suppose you want to go N1 to N3, so N1 to N3, I want to go N1 to N3, so what will be the part? First N1 to N3, and from via this is from N2 to N3, so N1 to N3. Okay, so sorry, N1 to N3 means first you go from N1 to N2 and from N2 to N3. Okay, so N1 to N2, it is 1, and n2 to n3 it is 6. So add this two, so it is now 6, and your corresponding, you go to n2 then go to n3. Now suppose n4. Now if you want to go to n4, suppose from n1 you want to go to n4, so what will be the path? n1 to n2 and n2 to n4. So n1 to n2 is 1, n2 to n4. Now what is n2 to n4? See, it is infinity. So 1 plus infinity is infinity. So again it is infinity. Now you want to go to n5. Okay. So n1 to n5 means first n1 to n2 and n2 to n5. So n1 to n2 means 1, n2 to n5. n2 to n5 is 3. So it is now 4, and next stop is n2. So see, in the second iteration, in the first iteration there are 3 infinities over there, but in the second iteration at least we can calculate the distance from n1 to n3, that is 6, and n1 to n5, that is 4. Okay. Now let us do another calculation. So let us find for anyone, suppose n5. Okay. So at n5, okay. So at n5, what are the information is coming? From n2 this part is coming, from n4 this part is coming. So from n2 I am getting what? I am getting this one, n2, that is 1 0 6 infinite 3, and from n4 I am getting what information? This part. Okay. So infinite 2 0 4. Okay. Now I want to create the new this one, n5 new routing table. Again, this is the destination, this is the corresponding new distance, and the next hop. Okay. So first I want to go n1. Okay, n1. So n5 to n1. Okay. So now there are 2 conditions you have to consider. That is, because there are two things now from n2 and n4, so there will be 2 paths, via n2, via n4. Okay. So first n2 to n1. So first I go from n5. I am going from n5 to n1. So from n5 to n2 I am considering this, and from n2 to n1. So what is the cost? n2 to n5. So cost is, suppose we are getting n2 to n5. n2 to n5, this is 3. Okay. So this is 3 plus n2 to n1. So n2 to n1, it is nothing but 1. This one. Okay. So n2 to n5 is 3, and n2 to n1 is 1. So I am getting 4. This is 1, either this, or we will consider this n2 to first n4. Now considering this one, and from n4 to n1. So n5 to n4, n5 to n4 is, n5 to n4 it is 4, and from n4 to n1 is infinity. So it is now infinity. So what is the minimum? 4 or infinity? It is 4. So the distance will be 4, and the next hop should be n2. Now from n5 I want to go to n2. So from n5 we want to go to n2. n5 n2. So there are 2 possible path, n5 to n2 and n2 to n2. So n5 to n2 it is 3, and n2 to n2 it is 0. Okay. Another possible probable path will be n5 to n4 and n4 to n2. n5 to n4 is 4, and n4 to n2 is infinity. So what is the minimum? this is 3, this is infinity, so minimum is 3, so this will be 3 and next hop will be n2. So like this way it will be n3, it is 6, next hop will be 4, so n4 it will be 4 and n4, n5, obviously n5 means n5 to n5 it is 0. See, n5 to n5 means what? There are two paths, either n5 to n5 or n5 to n4, and from n4 there are, this is round, there is 2 plus 6 plus 11, okay, and 4, so it is 0, it will be n5. So this is the new routing table in the second iteration. Similarly, I have created for n1 and n5. You can now create for n2, n4 and n3. Okay, so after 3 or 4 iteration, this entire routing table will come into a stable state. But it is not that it is always be a stable. If any changes happen, suppose any changes means suppose this link has been corrupted or something has been defunct, so in that case this information will be again shared to all other routing tables. Okay, so in this way you will calculate the distance vector routing. Okay, thanks.